Hello, everyone, and welcome to this 12th episode of my publication at a Glance. Today, we have the pleasure to welcome Dr. Claire Fleurisson, who did her PhD at the University Paris-Cité with Professor Laurent Miquen and in collaboration with Sanofi. And she's currently a postdoctoral researcher at the University of North Carolina at Chapel Hill. Today, she will share with us results that she had during her thesis about the synthesis of ASA spirocycles to explore the 3D space and to target RNA. Thank you, Claire, for being here. The mic is yours.
So thank you for having me to present my work on the design and evaluation of ASA spirocycles as RNA binders. So why are we interested in these RNA binders? It's because if you look at the human genome, actually a lot of it is transcribed into RNA, but a little proportion of the FDA drugs are targeting RNA. So we believe that there is actually therapeutic solution in this area. In the literature, they already used spirocycle to target bulges in the past, and our group also used pyrocyclophane to target hairpin. And we wanted to expand the chemical space around spirocycle. So we designed those two series of spirocycle that also has a diamine moiety and an aromatic moiety for the affinity. So the synthesis starts with a simple cyclopentadiene that we substituted and engaged in a disaldehyde reaction to yield this key intermediate. Then two oxidation and a reactive amination yield this piperylene. So we incorporated different groups, aromatic ones and aliphatic ones. Then the synthesis diverged in two. If you use a bromine compound, you get this tricycle through a Buchwald-Hartwig reaction, which is pretty rare on a diazo compound. Then we used flow chemistry to actually reduce this bond and yield the first series of spirocycle. The second series of spirocycle uses a ester derivative. So we deprotect the amine, and the amine can then cyclize spontaneously on the ester to yield this tricycle. We then use Birch-like reaction to actually cleave this bond and yield the second series of spirocycle. We wanted to test if our binder could actually bind RNA, so we chose TAR. TAR actually bind to TAT. If this complex is possible, you will have the complete synthesis of the mRNA of HIV. But if this interaction is inhibited, you will have a short version which is not viable. So we tested our compound using a fluorescence binding assay, a 2-amino purine system. And so the lower the KD is, the greater affinity it has. So first, if you look at the first series and compare the two substituents, you see that the KD is actually increasing nearly twofold when you go from an aromatic moiety to a cyclohexyl moiety, meaning that the aromatic compounds have a greater affinity. Then if you compare the two series, you see that actually the first series has a greater affinity because the KD is actually increasing twofold when you go to the second series. And even with the cyclohexyl moiety, you see that you go from a fairly good KD to no binding at all. And then we wanted to test selectivity, so we perform a KD experiment adding tRNA. For the first series, you see that the KD doesn't change. But for the second series, the KD is increasing threefold, meaning that the second series is less selective. We went further and actually studied the first series. And when you perform KD experiment, you see that actually the KD towards the bulge is actually decreasing, meaning that it has a greater affinity for the bulges. We also perform NMR study showing that this G is actually shifting a lot, meaning that this compound is actually most probably binding around this area. We also perform activity studies to see if this protein RNA complex could be inhibited. And we see that we have an IC50 of around a micromolar, which is pretty great for a first lead. So I hope we was able to convince you that we were able to expand the RNA chemical space, the RNA binder chemical space, opening new therapeutic solutions. And if you have questions, please reach out to us. And thank you.
Thank you very much, Claire, for this excellent and very clear presentation. To anyone watching this video, if you are interested in sharing your results in that way, do not hesitate to contact us. You have everything you need on that slide. Thank you very much and see you next time.